We move on to learn about Ohm's law. Ohm's law is an experimental law. It is based on experimental observation. It was observed for the first time by the German physicist George Simon Ohm. He noted that when there is a voltage difference between the two ends of a conductor, like here, VB minus VA, that is the potential difference or voltage difference, he noted that the current going through the conductor is proportional to the voltage difference. So we may write this relationship between current and voltage direct proportionality, and the proportionality constant R is equal to delta V divided by I, the voltage difference divided by the electric current I. This proportionality constant is called the resistance. So resistance for any conductor is measured in volt per ampere. Volt per ampere in the SI system has another name, which is ohm. We use the Greek letter omega. This is a Greek letter uppercase omega. We use it for the resistance unit. So 1 ohm of resistance corresponds to a voltage difference, 1 volt, giving an electric current of 1 ampere. So when the voltage difference is 1 volt, the current is 1 ampere, then the resistance is 1 ohm. For example, if the voltage difference is 120 volts and the current is 6 amperes, the resistance will be 20 ohms. 120 divided by 6, this is 20. And the unit is ohm. Resistance is measured in ohms. Usually, we use this symbol for resistance. Resistors can be fabricated in all kinds of forms depending on the application. These are called thin film resistors. These ones here, they are created from mixing mud with carbon powder and baking that, adding 2 electrodes, and labeling the value of the resistor using color code here. These are other resistors. This is called wire resistor. This is also some kind of wire resistor. We have variable resistors and we have fixed resistors. These ones here are variable resistors. When you turn the knob here, you change the value of the resistor. Regardless of the way the resistor is fabricated, we use this symbol for the fixed resistor. As I said, Ohm's law is based on observation. So this is what Ohm's observed. When he takes any conductor and studies the relationship between the voltage difference and the current, it is a linear relationship for most conductors, like copper wires, aluminum wires. It is a linear relationships. The slope here is 1 over R. Such conductors are called ohmic conductors. There are other situations where the relationship between I and V is non-linear. We call it non-ohmic, like the light bulb. As the light bulb gets hotter and hotter, the resistance changes, but not in a linear fashion. Changes according to this parabolic behavior. So for light bulbs, for diodes, for transistors, these are non-ohmic devices. But for wires, all kinds of wires, all kinds of conductor wires, it is ohmic behavior. The relationship between I and V is linear. In the figure below, does the resistance of the diode increase or decrease as the positive voltage increases? We see here the ratio between I and V, it is the reciprocal of R. So for this one, the resistance will decrease. So as we increase the voltage across the diode, its resistance decreases and the current increases. All electric devices are required to have identifying plates that specify their electrical characteristics. The plate on a certain steam iron states that the iron carries a current of 6 ampere when connected to a source of 1.2 by 10 to the power 2 volts. What is the resistance of the steam iron? To solve this problem, we just apply Ohm's law. R equals V divided by I. V is 120 volts and I is 6 amperes, therefore R is 20 ohms. The resistance is 20 ohms. We move on to learn about resistivity. Resistivity is an intrinsic property for all conductors. Each element has its own resistivity. You see here for silver, for copper, for gold. It is of the order of 10 to the minus 8, and the unit for resistivity is ohm meter. Resistivity depends on temperature. It changes as the temperature changes because the number of collisions between the electron changes as the temperature changes, because the electron gets more kinetic energy when you heat the conductor. The resistance of any conductor is directly proportional with its length and inversely proportional with the cross-sectional area A, and the proportionality constant here, rho, this is the resistivity. So now we understand from where we have the resistivity. It is proportionality constant. When we measure the resistance, it's directly proportional with the length of the conductor, inversely with the cross-sectional area, and rho is just the proportionality constant. So different materials will have different values for the resistivity. Suppose an electrical wire is replaced with one having a very linear dimension doubled. The length and radius have twice their original value. The wire now has more resistance, less resistance, the same resistance. To answer this question, you need to go to this equation and see how resistance changes with L and A. So the answer is resistance, because here when you double all dimensions, doubling R, because of the square, it becomes 4, factor of 4, while doubling L gets factor of 2. When you have 2 divided by 4, so this is 1/2. So yes, the resistance will be less.